quote of the week comes from Brad Paisley. Tomorrow is the first blank page of a 365-page book. Write a good book. Write a good one. So it's a fresh start to the year. This chapter of your book, make an interesting one. You control that chapter. The daily agenda for today, Tuesday, January 5th, 2021. Day 4, the daily agenda. We're continuing on with chemical bonding. Topic 8 is going to be balancing chemical reactions. We will start off with a warm-up. I have the wrong date on here. This is a warm-up from yesterday. You guys have class. This is the one I do want to do. So warm-up is 1-4-21. We have balancing chemical equations YouTube video. We'll take some examples of balancing equations, and next class we'll probably analyze more examples, and I hopefully will give you time for the exit pass next class as well. The attachments are below for what we need for today's class. All right, we're going to start off with, okay, yes, this is right. All right, we're going to start off with a warm-up. This is going to be pretty helpful for review. Some of you guys ask, are we going to review? Yeah, we'll do a lot of review. This warm-up will aid us and assist us in that review process. So you definitely want a reference table for the review. You want the last page. Maybe you want a calculator. Probably want a calculator for this as well. But this is going to help us out with reviewing for ionic bonding. So please click on the warm-up. Please complete the warm-up. The dates don't really coincide because I couldn't change the date on my forms. So it says warm-up 1-5-21, but then on the forms it says 1-4-21. So it should be these little snowmen up here all hanging out. And there's 5 questions on here for ionic bonding. Please take 10 minutes to try your best to complete the ionic bonding, and then we will go over it at 12 o'clock. So at 12 o'clock, we will review this. Please attempt this. I will put some work up here if you guys draw some brain farts and don't remember how to do it. So at 12 o'clock, we will review. Please work on this. Okay, hopefully a chance to go through those 5 questions on the warm-up. A lot of this would help you for the review of ionic bonding. All right, question number 1 reads, potassium forms an ion with a charge of what? So as you can see, I did do a lot of highlighting here to help you out in case you're stuck with this process. So potassium forms an ion with a charge of what? Please put the answer in the chat. Privately to myself. Thanks, Tintin. Thanks, Alex. Thanks, Nadina. Thanks, Emma. Thanks, Asim. Thanks, Alan. 2 more. Thanks, Leonardo. Thanks, Joseph. All right, so everybody that submitted an answer, oh, close, almost everybody. Most of the answers were A, some answers were choice C, no big deal. So we know it's got to form a positive charge. So positive charge, let me zoom in for a second here. Find your K, there's my K. It's going to form a positive charge for the ions, okay? It's definitely positive 1. So it's definitely A or C, I like that. Now, if I look at the electron configuration, the bottom left-hand corner, that's going to tell me if it's going to get a stable octet by either gaining or losing electrons. So 2881, which way is it easier to get a stable octet? To gain 7 or to lose 1? So it's going to lose that 1 valence electron, that last number. Once you take an electron off, they're negative, take an electron off, throw it away, you become positive. So the best answer should have been choice A. Most of you guys put it, choice A is definitely the best answer. 1 is A. Next up, number 2. Question reads, an ionic compound is formed when there is a reaction between the elements. Please put the answer in the chat. Thank you, guys. A lot of answers. They all are the same. So choice A looks like a good answer. Ionic compound is going to be a metal and non-metal. I tried earlier highlighting my metals. Metals are to the left, and non-metals are to the right of the staircase. So metals are in the pink, typically, and the yellow is typically my non-metal. So H and He were non-metals as well. So if we're just checking out those elements, doesn't look really good now, but guess I erase them. So strontium and chlorine. Strontium and chlorine, if you locate them, you probably need to use the next page to find the symbols, but there's strontium, metal. Chlorine is a non-metal. Looks like a pretty solid answer, metal, non-metal. Next choice is hydrogen, H, non-metal, and chlorine, 2 non-metals. Not a good answer. That's a covalent bond. We'll get to that shortly in class. Next choice, choice C is nitrogen and oxygen, N and O, both nonmetals. And the last choice is sulfur and oxygen, S and O, 2 nonmetals as well. Metal, nonmetal, ionic bond, definitely no. Choice A is the best answer for that one. So choice A, metal, nonmetal. Number 2, best answer is A. Number 3, what's the name for the compound whose formula is N2O? This one's a tricky question because it's not an ionic compound. It's a covalent compound, but we should be able to use our knowledge from that and hopefully find an answer for this one. Try it out. Please put the answer in the chat for number 3. What do you think it is? Thanks, Asim. Thanks, Alex. Wendy, thank you. Thanks, Santino. Welcome to the party. Thanks, Urban. Thanks, Kai. All right. So why did I say it's a trickier question? Because we didn't go through covalent bonding yet. We are analyzing N2O. N2O. Those are both nonmetals. They're both covalent bonds. But we know the first element. Let's just analyze this a little closer. So the first element, N, has 2 nitrogens, and there's an O. Hopefully you know the format of a bond or name a formula. It's got to be a positive charge. followed by a negative charge. So it's always going to have that format, positive by a negative. So even though it's a covalent bond, there's still going to be a positive charge followed by a negative. If you think about this process and where these values or the subscripts came from, you could take the two charges and reverse them back on up. So reverse them back on up. This is going to work its way back up. It's going to gain that -2 charge. So it's going to be -2. And then whatever this charge is going to work, there's a subscript of 1. That 1's going to work its way back on up to the nitrogen. So reverse crisscross. So the formula comes from N with a +1 and O with a -2. If you had those charges, you should be able to crisscross those charges to get the formula. Criss 1 cross. Take the absolute value and crisscross those charges. And that's what the formula is above. But anyways, checking it on out, we have nitrogen. We can't get rid of anything by nitrogen. That's the name of the element. And you have oxygen. Take ox and add "ide." Take the first syllable and you add "ide." So again, you can't take away anything from that naming either. So the only difference here is this Roman numeral. What's the Roman numeral going to be referring to? It refers to this charge right there. So nitrogen 1 is a pretty darn good answer. Nitrogen 1 is a solid answer for number 3. If we check out nitrogen, there's a ton of charges for nitrogen. We could have eliminated, so if we look at nitrogen, you could have eliminated several answers right from the get-go, such as it's not going to be negative. Those first 3 charges are not going to be appropriate. Which charges are referring to below, and that's what we just solved for. So it's got to be a positive charge in this situation. And this time it's referring to +1, that one right there. So nitrogen 1 oxide is the best answer for that. Trickier question. Ooh. Question number 4 is asking for a GFM. Hopefully you didn't forget GFM over the break. Maybe you had time to work on some more GFMs, gram formula masses. Maybe not. I don't judge. We'll get back out again. What's up for the molar mass? Is the molar mass for BaOH2? I did solve for this already. It's in the blue little text box below. GFM for BaOH2. All you had to do is figure out the ion, the number of moles, and then multiply it by the mass. You do that for every ion in the compound. I got a GFM of 171.3. If you followed along with me, you probably saw that I forgot my H. That's why my math didn't come out right the first time. So 171.3 is definitely the best answer for number 4. Does anybody want further explanation on that one? So definitely know how to do GFMs. It will be on the benchmark coming up. The last question, number 5. 5 is asking about what's the total number of atoms represented by the formula with CuSO4 with a hydrate, 5 moles of a hydrate stuck inside, 5 moles of water stuck in that crystal. So all you gotta do here is figure out how many moles of each atom are present there, and then add them all together. Add them all together. We should have gotten choice C is the best answer. So I want to know the total number of atoms represented by the formula. Add them all together, hopefully distributed correctly. So don't forget that 5 is outside the parentheses. That has to get distributed to everything inside. I'm sorry, it's outside. It's a coefficient. It has to get distributed to everything in the compound. So coefficients are distributed to everything in the compound. So choice C is the best one for number 5. Does anybody have any questions on 1 through 5? Okay, again, the warm-ups, I am not grading at this point. You guys received your 5-week reports for the second quarter. And I told you guys the exit passes were the solely of how I grade you guys for the 5-week period. So if you did the 5 exit passes, 1, 2, 3, 4, 5 for ionic bonding, There was one on ions. There was one on ion formations. There was one on GFM, moles, all that stuff. If you did those, you did well on them, you paid attention, then your 5-week report was pretty solid. If you missed 1 or 2, then your 5-week report wasn't the best, but you still can make up those exit passes. I will allow you to still make up the exit passes from previously to the 5 weeks. If you didn't do it, do it. The warm-ups don't go towards your grade because I go over them in class. It's a chance to reflect on the previous classes. So just know that your exit passes are mainly how I'm grading this year. All right, so we're done with the warm-up. Now we're going to go on to balancing chemical equations. The rest of the class is going to be like examples of how to balance a chemical equation. So before I get to my notepad, I'm going to start off with this video on balancing chemical equations.
For balancing chemical equations, you want to make the reactants be the same exact number as your products. Always start with balancing everything other than hydrogen and oxygen. Leave hydrogen and especially oxygen for the very end. All right, let's get started. Here we have an unbalanced equation. Our first step is to write all of our elements for our reactants and all the elements that we have for our products on either side, and I'm going to keep them in the exact same order to make it easier to balance. Now, my tip for you is for any polyatomic atoms on the same, that are the same on actually both sides, like our OH and our OH here, do not separate them. We're going to leave the OHs intact to make it a lot easier to balance everything out. All right, so now let's get back to our reactants and see how many of each reactant we have. Looking at barium, we only have 1. Chlorine, this subscript tells us we have 2. Na, we only have 1. OH has no subscript or parentheses with a subscript, so then we're just going to say that there's only 1 OH. Now going to our products, we'll see that barium only has 1. Now I'm going to look at OH for right now and see that there's actually a 2 subscript. That 2 only affects the OH group, not barium. So this is saying there are 2 OHs. So 2 OHs. And then we'll have 1 Na, or sodium, and 1 Cl, or 1 chlorine. Now, the next step is to figure out, okay, where are we going to start? What do we want to balance? So we have to balance out our chlorine because there's 2 on this side and only 1 on the other. And then for OH, there's only 1 on our reactant side and 2 on our products. Always begin with everything other than hydrogen and oxygen. So I'm actually going to start with the chlorine first. So since there's a 2 here, I need 2 more on the product side. So I'm going to place a 2 right in front of that compound. Note that you cannot put the 2 in the center because that's then breaking apart the compound altogether. And since this is a compound, this 2 will actually distribute and affect the Na and the chlorine. So I'm going to actually recount everything now. If we were to recount everything, we'll see that we have 2 Nas and now we have 2 chlorine. But nothing changed with barium or our OH. We still have 2. Now looking on the reactant side, I'm going to now continue to balance out the Na. So we need 2 on our reactant side. This would then distribute to both again, and we'll see that this affects our Na because we now have 2 on that side and we have 2 OHs. Everything else remained the same and we're balanced. Here we have our next unbalanced equation. Remember to start with writing all of the different elements you have for your reactant side and for your products, keeping that in the exact same order to help you balance it out. Now, I'm always going to leave hydrogen for the second to last and oxygen for the very last. It makes it so much easier. Oxygen tends to balance out at the very end. Now, looking at this, I'm just going to count how many of each element we have. So looking at this subscript, we have 2 carbon on our reactant side. Looking at the 4th subscript, we have 4 hydrogen and 2 oxygen. Now looking on our product side, we'll see there's only 1 carbon. That 2 affects this oxygen. However, there's actually another oxygen here, so don't forget about that. There sometimes can be other oxygen in other compounds, and I'm going to look at this and actually count it up. So there's 2 plus that 1 oxygen, making there be 3 oxygen on our product side. Next, we only have 2 hydrogen due to this subscript. And let's look and see, and really nothing is balanced whatsoever. We have our work ahead of us. So looking at carbon, that's where I want to begin, because remember, hydrogen is second to last, then oxygen. So carbon, I can place a 2 right in front of that CO2 compound, and this affects our carbon and our oxygen because it's like you're distributing. And I say that because we're going to multiply this 2 times this other 2 for our oxygen and then recount everything. So if I'm going to recount and see what's affected by this 2, there's actually 2 carbon on our product side and 2 times 2, so 4. 4 plus this other 1 oxygen, making it 5. So we now have 5 oxygen on our product side, and nothing happened with hydrogen, so that stayed the exact same. Now let's go back to our reactant side, and then we'll balance out our hydrogen. So we'll see there's only 4 on this side, and we have only 2 on our product side, so I need 2 more, because you're looking at what will multiply by this subscript to give us 4. So 2 times 2 gives us 4. I'm going to recount everything again. So this would have been 4 hydrogen, and nothing else changed except our oxygen did, right? So because I'm going to actually distribute that 2, our hydrogen changed and our oxygen, now we have 2 plus the 4 that was here, so we now have 6. Almost done. Last thing is oxygen to balance out. So what do we need to multiply oxygen by to get 6? So 3 times 2 will give us 6. So I'll place a 3 in front of that O2 and recount everything on our reactant side. And we'll see that 3 times that 2 gives us 6. And right there, we are balanced. I did another video with more practice problems balancing chemical equations. Make sure you check that out, because guys, to really understand chemistry and to not have to take this class again, practice is truly the key.
All right, so let's practice some balancing some chemical equations. Next couple classes is going to be a lot of examples. We'll practice them, and you'll become more proficient at these as well. Please open up your guided notes for unit number 5, chemical bonding. So please open on up. We'll do a little review session here as you're popping this open. You'll hear my spiel since it's been a while since you heard it. We've been on this unit for over a month. You can see that. We started on the 30th of November. All right, so unit 5, a lot of stuff is in this unit, so that's why we took some time on it. Unit number 5 is on ionic bonding, part 1. We're still finishing up ionic bonding. We're almost done though. Topic number 1 was reviewing ion formation. So we should know what an ion is. An ion is going to be an element that, or an atom that has lost or gained electrons. When they do that, they're going to behave like the nearest noble gas. So noble gases have 8 valence electrons. When an atom bonds, they want to get to 8 electrons. We analyzed several ions, and we were able to configure and figure out which noble gas they were like. We named ions, positive ions specifically. When there's only one charge for the positive ion or metal, it was just the name of the element. When there's more than one charge, then you had to identify the element and then the Roman numerals in parentheses. So we did that. More than one charge, then Roman numerals have to be indicated. Non-metals, the negative ions, when they gain electrons, it's going to be the first syllable, and then you add "ide." We talked about forming bonds. When 2 atoms come together to form a bond, they hit. When they collide, what happens? Friction happens, and heat is released. Breaking of bonds can be opposite. We talked about ionic bonds of metal and non-metal. They transfer electrons. We drew a Lewis dot diagram for an ionic bond of Na and Cl. You should know ions, positive ions, they don't have any electrons around it. They have the brackets and the charge. Negative ions have the charge, all 8 dots in the brackets. Covalent bonds are 2 nonmetals. They share electrons. There's no brackets. They're closer together. We went through, we talked about Leo says Ger, loss of electrons, oxidation. The gains of electrons can be reduction. We drew an atom, a Bohr ring, and a Lewis dot diagram for an atom. We also compared it to an ion, 2 different ions there. We talked about ionic bonding in terms of electronegativity. If the difference is greater than 1.7, it's going to be an ionic bond. We analyzed several examples there as well. We took a binary compound, we took the charges and we crossed them on up to come up with a formula. We talked about properties of ionic bonding. We took the charges and crossed them again for binary. We took a formula to derive a name for binary compound. Missed a couple there, but I think we did those too. We went from a name to a formula for binary compounds, but we also did it for ternary, which means more than two elements bonding together. Ternary compounds, there's a Python ion that was on page 2. We went from a name to a formula. We also went from a formula to a name for ternary compounds. We talked about 4 different types of chemical bonds, chemical formulas. Molecular formula, empirical, is simplified. Structural formula, and then these ball and stick models as well in the shapes. We talked about moles. You should know what a mole is. You know how to tell the difference between moles of an atom. You distinguish different numbers of moles. We did that, and then we incorporated GFMs, gram formula mass. Took the number of moles, times the mass, then you added them all together. Multiply, then add them all together. So if you need more review on GFMs, check that out in the notes. They're there for you. We figured out number of moles. It's on the last page of the reference table. Given mass over the GFM, there's a work on it. We analyzed several examples there as well. Then we went to percent composition. Percent composition, last page of the reference table. This formula is here too. Percent equals part over whole times 100. We also did with percent of water trapped. Moving on, we talked about types of reactions. So last day before break, we went through types of reactions. We took 2 elements and bonded them together. We added them together. That's called the synthesis or an addition reaction. 2 elements form one thing. It's an addition. If a compound breaks down to 2 smaller things, that's called decomposition. Single replacement or substitution has a format of an element plus a compound. Yields a new element is isolated, plus a new compound is formed. It's typically going to look like that. Substitution or single replacement. Double replacement reaction looks like the most complex type of reaction, longest expression. It's a compound plus a compound yields a new compound plus another new compound is formed there as well. And last but not least, we left off with combustion. I think of combustion as heat or fire. If you burn an alcohol, you need oxygen gas. And when you burn it, you get water and carbon dioxide as the products. That's where we left off. So hopefully you found your notes. Give you like 4 or 5 minutes to do that. So I went through that. I'm on page 21. I don't know where you are, but hopefully you're staying current with me. This is what guides our class. This is what drives our class. Next topic. So we're going to be filling out a small section of notes right here. And then the examples, we'll do like 3 or 4 examples within this as well. So this is going to be topic number 8. Topic 8. And this is going to be balancing chemical equations. So please fill this out in your note packet. This would have been a paper like I passed out to you guys. That's why it's not in here. Topic 8. This is balancing chemical reactions. It's going to feel like a math class. That's our goal. Balancing chemical reactions for today. It's going to be like a mix of a math and a tech class, computer class today. Every day is like a computer class. All right, so from that video, hopefully you got some information from it. When you balance a chemical equation, the first thing you have to know is when you balance, your chemical reactions must obey the law of conservation of masses. So the balancing a chemical equation, it must obey the law of conservation of masses. Must. What does that mean? It means whatever's on the reactant side equals the product side. I'll throw that here as well. So the reactants equal the product side. when we balance chemical equation, there's only 3 easy steps, 3 steps to balance a chemical equation. I'll call this one steps to balance chemical equations. I promise you, there's not a lot to really write down. 3 steps and that's it. So steps to balance chemical equations. I'm gonna add my numerical bullet next. Step 1, balance the metals, which are positive ions. Step 1, balance the metals. Once the metals are balanced, go to the next one, step number 2. Step number 2 would be balance the nonmetals, which are negative ions. The only ones we're not going to balance for nonmetals are going to be, there's 2 exceptions, except the popular ones, H and O. Step 3, balance, you guessed it, H and O. Sorry, I'm yelling at you with these steps, but they're easy steps. You should be able to memorize these steps. They're not that in depth. Step 1, balance your metals. Step 2, balance the nonmetals, except for H and O. Step 3, balance H and O. That's it. That's it for the notes. Now we have examples for the rest of the class today. So this is what page of the notes someone asked where we're doing it. It's just going to be actually after my topic 7. So this is an insert you're going to have to add into there yourselves. If you want to put it on some piece of paper and just input it to the notes, that's totally fine as well. So this is what you had to add on my page. I think it's page 21, but your font style could be different. It's 21 on mine. Hopefully that helped, Emma. So again, I just added it after topic 7. Got a new mug for the holiday. Little guy. He's gonna be 1 soon. Right here. Like 10 days. I'll be using this a lot. It's my bull. Fun times. Best thing ever when time's right. Take care of yourself, take care of your future. And then you can take care of someone or something else. All right, does anybody need more time for copying down the steps? Please let me know. Okay. So I clean up my Zoom room, try to make it more attractive in here. There's my little classroom wall. This is it, guys. I don't know how long we're gonna be like this, but I'm settling in. Hopefully you are too. Hopefully you have a routine at home. Okay, when you're done with that, we're going to do at least 3 examples of how to balance. Once you're done with that, I'm going to press enter a couple times, and I'm going to add this into a cell so like all my work is in that cell. So I'm going to go to insert table, not drawing, insert table, and then just one cell. Insert table and one little cell. That's cool, Faith. Just saw that message. I'm sure she liked it, loved it. All right, so just one cell. And this is going to be example number 1. I'm going to get rid of my cap locks. I'm not going to yell anymore. My voice like hurts after I keep yelling. Let's be a little more subtle. I'm going to fill it in with a background color. I'm going to paint it. You don't have to paint it. It doesn't have to look exactly like mine. Got a background color, and then I'm going to ask that you try to copy this so it's the same as mine. The first couple examples I'll definitely do, and I'll try to guide you through the process. Maybe the last one I can have somebody help me with. So the first example is going to be, there's going to be like a little space for a coefficient. That's like a little dashed line on the bottom. How do I get that dashed line? It's just shift and then the dash, which is between the 0 and the plus. I hit it twice. And then it's going to be Li spacebar plus dash line 2 times N2, which is a subscript, so it's control comma. And I'll blow this up in a second. Control comma again brings it back on up. Dash dash shift period gives you the yields. And then shift dash dash Li3N. Let me blow this up. Question: the Regents would say, balance the chemical equation below. That might be a question. So please make sure it looks like mine. If you have a different number, then it's not going to work out for you. Please make it look similar to mine. Okay, once you're done with that, I'm going to ask that you copy it. So highlight it all. Control C, copy. And I'm going to paste it onto a drawing pad. So the drawing pad's like my scrap paper. So copy it, and I'm going to insert, drawing, new. And there I'm going to paste it by hitting Control V. I can just stretch it on out. And I can mark it up pretty easily now. Does anybody need to see that feature again? All right. So here we go. What I do there, I just highlighted all of it, highlight all the information. The Li plus N2 yields Li3N. Highlight it, hit Control C, copy, or you could click 2 fingers down on your keypad, copy. I wonder what that would do. Copy. I'm going to go to Insert, Drawing, New. If you have a Chromebook, 2 fingers down your Chromebook, or get Control V, and that pastes it on in. So copy, paste that on in, drag it out, so it's going to make it larger. And now it's going to say balance the chemical equation. Does anybody need a refresher one more time? Okay, cool. I think we all got that. All right, so the first thing when you balance the chemical equation, you have to have the reactants equal the peroxide. So what does that mean? It means whatever's on the reactant side has to equal the peroxide. So if there's 1 lithium here, there's got to be 1 here. So you got to balance them both out. It's like shifting them back and forth. So a lot of times you're going to go back and forth and try to find out how to balance these chemical equations. But to balance, you can't add a subscript. You can't just say, hey, I want to balance this out by putting a 3 there. You can't do that. The only thing you can do is add a coefficient out in front of the number. So it's got to be a big number, a coefficient out in front. That's the only thing you can manipulate here. So the first thing I would suggest when I'm doing balancing chemical equations is put a line right down the middle of the arrow. So I'm going to add a little line. I'll take that line, put it straight down because I want to really divide my reactants and my products. I'm going to switch the color of it and make it pop out a little bit more so I know this side over here is equal to the right. Once I have that, I'm going to add a text box. A little bit big, a little bit longer than I need. And then I'm going to compare every element in the reactant side and figure out how many moles of each element there are. So I go through this process, click in my text box, and I would say Li is the first element listed. And I would say that there's only 1 mole of lithium. And then below would be the second element, nitrogen. How many nitrogens? There are 2 nitrogens. So there's the reactant side. I know how many of each atoms I have present there for the reactant. Once you have that, you're going to do the same thing on the product side. But before you do that, you want to keep them in the exact same order. So you want it to be Li and N on the product side. So here we go. Make another text box over on the product side. Great. So you could do this on a separate piece of paper if you want. I'm not going to this time. All right, so Li, how many moles of Li I'd ask, and you'd say there's 3 Li's. And then I'd ask how many N's are present there, and you would tell me there's 1 mole of nitrogen. All right, so now it's easy to really compare these values on both sides. All right, next up, I would be go through my steps. So step 1 would be balance the metals, locate your metals. Hopefully you have a reference table handy. I'm not gonna go back and forth to a reference table. But metals, there's a lithium, that's a metal, and N is a nonmetal. So N is a nonmetal, so the top right of the periodic table, that's a nonmetal. So step 1, balance the metals first. So lithium is the first one we're focusing on. There's 1 lithium on the left, there's 3 on the right. How would I balance this? You're gonna have to make 3 on the left. You're gonna have to add 3 moles of lithium to the left. So I can't just say, oh, cross this out and put 1, we're good to go. You can't do that. You can't take away when there's a subscript. So I balance it out. The first step I have to do, I want 3 on the left. So I'm gonna add a coefficient of 3 over here. So I'm gonna get away from my zoom annotate so we can do it all together. So I'm gonna add a coefficient of 3 right there. When I have a coefficient of 3, it's gonna change my lithium to 3. Step 1, balance the metals. They're balanced. Step number 2 would be balance the nonmetals, N. So I have 2 to the left, I need 2 to the right. How am I gonna make 2 nitrogens to the right? You could add a coefficient of 2 in front of the compound Li3N. Once you do that, if you add that coefficient there, it changes a couple things. It's gonna change lithium. Now lithium is gonna be 2 times 3. That's gonna now be 6. But it also changes nitrogen because you're distributing this coefficient. Nitrogen now is gonna have 2. So my nitrogen, if you look at this, nitrogen is now balanced. Good. But my lithium's not balanced, but that's not a big deal. We could switch that out pretty easily. Balance out my lithium. There's 6 on the right. We need 6 on the left. That's easy. Just get rid of this coefficient. Now we're going to change this to a 6. And that's going to change lithium to a 6 as well. I know you can't, you could probably draw on this, but I'm not going to go with that feature. I'm going to get rid of this drawing. Hopefully you followed along with what I did there. So let's fix this up a little bit. Now we change lithium to 6. This is now going to be 6 for lithium. And I have to change this number to 6 lithiums and 2 nitrogens. Now, if you're comparing your data, 6, 6 even, 2, 2 even. Coefficients would be 6. There's nothing there, so that would be a 1. It's not 0. It's a 1 and a 2. 6, 1, 2 would be the coefficients for a balanced chemical equation. 6, 1, 2. Start off relatively basic. We'll definitely get a little more difficult a little bit later. You could put a 1 there. You don't have to. The reason why I suggest putting a 1 is because sometimes they're going to ask for the sum of all the coefficients. So sometimes they're going to ask for you to add all 3 of those coefficients together. And if there's not a number there, sometimes people won't remember there's 1 there. So coefficients are 6, 1, 2. Or the ratio is 6 to 1. All right. There's the first example for balancing a chemical equation. Do like paper so you can see this little distribution process. Crossing out numbers, I like that stuff. All right, first example, save and close. Hopefully, I knew it. I knew it when I zoomed out. That's why I said, oh, shucks. Got me. All right, so if it happens to you too, all I have to do is refresh and get back down to the bottom of your page. 21 pages of your blank pages of chemistry. Just like our quote of the week. 22 pages of chemistry. 22 blank pages of chemistry. You control it. But it's a good way to review, again, see what we learned for a month, whole month of chemistry. What we learned. Hopefully something. All right, so if you have the same problem that I do, I'm going to double click on my image and I'm going to highlight it all. I'm going to cut it and I'm going to paste it back in. So Control X and then Control V to paste it back in. And hopefully it saves it this time. It does. It's a little small. You can blow it on up if you want to. If your text box is too big, you don't like it that big, you can make it smaller to fit the screen. I'm just going to make mine a little larger. All right, so there's the example for the first one for balancing a chemical equation. Start off relatively easy. Let's try another example. Does anybody have any questions on what I did there or how I did it? The more practice you have, the easier it will be. All right. No, thank you, Asim. Thank you very much. All right, second example. So I'm going to scroll below it, and I'm going to add another cell below it. So again, it's going to be similar to what I have there. I'm going to insert table, one box. Example number 2. So example number 2, we'll call this. I'm going to fill it in with a color. I don't care what color. Let's go green. And this time the example is going to be Mg plus HCl yields Mg Cl2 plus H2. Let's see what we're dealing with now, what we're working with. Balance this bad boy. This chemical reaction. All right, example number 2, we're balancing this reaction. Mg plus HCl yields MgCl2 plus H2. Once you're all set with that, you could highlight it all. We're going to copy and paste it back into the drawing pad again. So highlight it all, Control C, insert, drawing, new, paste it into my drawing pad by hitting Control V. I can stretch it out. That's what we're going to balance. So again, you should know that, put this portion in. This is my reactant, yields the product. And you want both sides to be equal. So reactant side is equal to the product side. First step I'm going to do is going to add a line down the middle. Does anybody need more time before I start? I'd rather have you guys pay attention somewhat and not scramble. I gotta tell you, I'm amazed like how good your connections are with the internet. I feel like I lose connection more than you guys do. All right, so the first thing is gonna be to put a line down the middle from my reactant to the product. And again, the reason why I do this, it's just gonna divide my reactant and product. It allows me to compare a little bit easier. Next thing I would do is go through each element in the reactant and compare and say how many of each elements are present. I would say, hey, how many mg's are there? And you would tell me there's one. I would say, hey, how many h's are there? And you would say, there's one, Mr. Brown. And I'd say, hey, how many cl's are there? And you'd say, there's only one. And I'd say, that's pretty easy to do. You know how to do that from GFMs. The last question on the warm-up was very similar to this because I wanted to introduce this topic. That's why I did it. Next step would be compare the product side in the same manner. So organize them so you have Mg, H, and Cl in the same order. So what I do, I typically go through each element of the reactant and however they fall or lay like that, that's how it's going to be on the product side. So you could rewrite them again, or I'm going to copy this text box and paste it over to the right and just use my arrows to scroll on over. But obviously, you're going to have to rewrite the values again. So I want the same order again, Mg, H, Cl. And I'd say, hey, on the product side, how many Mgs? You'd say 1. I would say how many H's? There's 2. And how many Cl's? There's 2 as well. And then I would say, let's balance this equation. I would say step number 1 would be balance your metals. Find your metals. My metals are going to be Mg. Step number 2 would be balance my non-metals, except for H and O. So step number 2 would be balance my Cl. And the last one, step number 3 would be balance my H. So Mg's first, Cl, then H. Let's do this. Mg's are balanced. Good to go. Don't touch them. I'm going to skip H. Cl's are not balanced. So I need to balance my H. I'm sorry. I need to balance my Cl because those are not equal. Not equal. And I say, how do you balance those? There's a 2 on the right. I need 2 on the left. So how do you balance the Cl? You would put a coefficient of 2 in front of the Cl. This would change my H to 2. This would change my Cl to 2. Man, that was an easy one. So that changes both of those, just like that. Then you say, what would you do next? And you would tell me, Mr. Brown, they're balanced. Those are balanced now. So if you wanted to put more coefficients there, you could put a 1 here, a 1 here, and a 1 here. Compare both values, balanced, balanced, balanced. Let's fix this on up, and you could fix your end up too. So here we go. So coefficients, hopefully you followed that. There's a 1 there. There's a 2 in front of the HCl. Oops. There's a 1 in front of MgCl2, and there's a 1 in front of H2. Balance them on up. 2 H's, 2 Cl's. If you follow the process of balancing metals first, then balance the non-metals, and then balance your H and O, then it really does fall into place. Some are easier than others. That was probably the easiest one of the easier ones I've seen. Any questions on how to balance the second example? Once you're set with that, you can save it and close it. Oh, come on. Gotcha. Got me again. I think it's because I use the annotate from Zoom. So on some more sad news, my friend works at the hospital, and she said that in the morgue is full of deceased bodies, partly from COVID or other sicknesses going around right now. The morgue is full, and they have no more room for deceased bodies. So now they're putting these bodies that passed away into trucks, tractor-trailer trucks. I think it's crazy. Like, someone dies and they're throwing someone's body in a truck because there's no room. It's not a joke. It's serious. But I remember hearing, like, on the news, like New York City way back in maybe May, April, how there's no room in the hospitals, and they had to get these tractor-trailer trucks because there's no room for the morgues. It sucks that, like, this is our area, and that's what's happening in our area now too. So that is definitely what's happening locally. That's why we're not in school. Hopefully you guys and your families are taking this serious. If your parents work in the hospital, thank them for me. All right, so there's my example. I'm not trying to scare you guys. It's a pandemic. This is not something that's going to happen probably ever in your lifetime. All right, example number 2, done. Let's check out one more example. 10 more minutes to go here. Step it up a little bit. Harder example. Okay, last example, then I'll get you guys out of here. Example number 3, again, add another cell, insert table cell. This is example number 3. And I'll make this one a little bit more difficult. The example is going to be Fe2 parentheses SO4 3 plus KOH yields K2 SO4 plus FeOH3. So please take your time to copy that down. You just check over it, make sure that's accurate, precise. So it works out here. Okay, so this is the last example we're going to do. I'm going to actually fill it in with a color here as well. Okay, when you're ready, please highlight the formula, copy and paste it, copy and paste it into drawing. insert, drawing, new, and paste it on in. And again, you're following the same steps as what we've done for the last two examples. So if any volunteers that want to talk to me, help me out with this example. I know it's been a long class of Mr. Brown just talking, rambling on. Anybody want to help me out? I won't pick on you too much.
I can try.
Thank you very much, Kai. All right, Kai, how was your break?
It was boring.
Boring. Sorry to hear. Like, oh, I get it. You made borings all break?
No, no, I don't want to do any more borings.
Oh, come on. They're not that bad. All right, Kai, the first thing I would do, I'm just going to guide you a little bit. I'm just going to put a line down my yields from reactant to product. I'm just going to ask you some questions. Hopefully you could pop some answers out to me as well. Hello, ma'am. There's a couple guest appearances today. All right. So anyways, how many FEs are present here?
There's
On the left side.
two.
Two FEs. So as Kai does this, hopefully you can do this as well. So there's two FEs. How many sulfurs?
Three.
Three sulfurs. How many oxygens?
12.
12. So oxygen. So this 3 outside the parentheses, little heads up, 3 outside the parentheses gets distributed to everything inside the parentheses. So Kai took 3 times 4, which gave her 12. But don't forget this guy over here. So 12 plus that last one over there, that's going to give you 13. How many potassiums?
There's one.
1. How about hydrogen?
One.
1. So that's not too tricky. You had to go through, figure out how many of each of the atoms are present in the compound. Now we're going to do the same thing on the product side. So I'm just going to, I guess I'll add another text box here. I was going to copy and paste, but I'm going to add a new text box in case you don't want to do that. All right. How many FEs are on the product side?
One.
1. How about sulfur?
One.
1. Oxygen, keeping that order.
4.
4 plus. Some more over
5.
there to the right.
12.
So 5. So 4. Let me get my pencil out again. So you have 4 here, plus you have the 3 that's transferred inside the parentheses. So 4, 5, 6, 7. So it should be 7. 7 oxygens. Next element is K. How many Ks?
2.
2. And last one, H's. How many H's?
3.
3. All right, that is definitely the first step. You have to figure out how many of each atoms are present in the compound. Does anybody have any questions on where we derive any of those values? All right, Kai, step 1 is balance by metals. Which elements by metals?
Fe.
So we're going to balance Fe first. Is there any other metals here?
Potassium.
Potassium. Potassium is the other metal. So those are the first 2 we're going to balance. Second, we're going to balance the non-metals except for H and O. So we definitely have to balance this next, sulfur. And that's it. H and O are going to be last. All right. So we're going to balance the metals first. Fe is not balanced. How many make my Fe to the right balance out? How many get 2 on the right? How many get 2 irons over here?
Or multiply by 2.
Put a coefficient. Yep, put a coefficient of 2 on the right. So if I put a coefficient of 2 over here, then that's going to be distributed through everything in the compound. So there's going to be now 2 FEs. I'm going to change that in a second. 2 here. There's going to be now, oh, that's going to be distributed throughout. But also don't forget you have to distribute these inside the parentheses as well. So oxygen, you have 3 times 2 is 6, plus the 4 over here as well. So oxygen, there's going to be 6 plus 4, 10. Hydrogen, there's going to be 3 times 2 is 6. So that's going to change to 6 as well. Questions on that? Do you have any questions on that, Kai, or are you all set with that one so far?
I'm set.
All right. All right, I will, I guess I'll let me get rid of my annotate here so I could change it so you could change yours as well. So I changed my Fe to 2. Now I have my oxygen, 6 plus 4 was 10. And hydrogen, we changed that to 6. Fe's balanced. What do you want to balance now?
Oxygen.
Balance the metals first. So metals, Fe is a metal, and so is K.
Potassium.
Yep. How are you going to balance this potassium?
I'll put a 2 in front of the KOH.
KOH, good. So put a 2 in front of that KOH, definitely. Once you put that 2 in front, then it's going to distribute. You now have 2 Ks. Distribute that 2 to the O, distribute to the H. So I have 2 O's plus your 4 times 3. So 2 plus 12, 14. And your hydrogen now we have is 2. So let me change those on out as well. 14, 2, 2. 14, 2, 2. All right, 14, 2, 2. Step 1 is balance my metals. Fe's balance, K's balance. Good. Step 2 would be balance my non-metals except for H and O. What do you want to balance next? Which element should we balance next?
Sulfur.
Correct, sulfur. How are you going to balance sulfur?
Putting a 3.
Good.
Coefficient.
Coefficient of 3, you got to change, obviously that one. Coefficient of 3 in front of K2O, K2SO4. Don't forget to distribute. Distribute, we have 3 times 2 gives us now 6 for K. Then we have 6 for K. Make sure I did that right. And then we had 3 sulfurs. Oxygen is going to be 3 times 4, which is 12. Plus oxygen over here, we have 3 times 2 is 6. So 3 times 4, 12 plus 6 gives you 18 oxygens. We're so close here. I know there's like less than a minute, but we're real close now. All right, so step 1, balance metals. Fe's balanced, K's not balanced. We have to balance the K. There's, I think, what is that number? 6? K should be a 6 on there. Yeah, it's a 6. So balance your K. How do you balance it? You're going to change this to a 6 over here. That's going to change K to 6. That's going to change my O to 6 plus 12, which is 18. And then your H is going to be equal to 6. So I know it's time to go, but I'm just going to fix these coefficients quick. The coefficients would now be 1, 6, 3, 2. 1, 6, 3, 2 should be the coefficients for that one. Thank you, Kai, for your help. I appreciate it. I will straighten this up, but if you guys have it straightened up, you're good to go. You could start your exit pass, but I'd wait for more examples tomorrow. So next class, we'll do like 4, 5, 6 more examples, and you'll have the exit pass as well. On that note, that's it for today's class. Thanks for your help. We'll see you guys tomorrow. Have a great day. Stay safe. See you later. Bye, guys. Bye, John. Have a good one. Bye, Kai. Bye, Nadina. Bye, Kim. Have a good day. We'll see you later, guys.